All right, Com 400 students, somebody in class last time left their wallet, and so if you're the one who lost the wallet, please let me know. I think it's a hot wallet, so if you lost a wallet, just let me know. Okay, let's go ahead and get started with the real stuff. We're talking about probability sampling, and we're going to look at a couple different aspects of that, and I'll give you some specific definitions and explain what that means. Probability sampling, we talk about using systematic sampling techniques which assure random selection. And there are specific ways, techniques of doing that. Basically, it uses a system such as picking a number after every nth possibility. And I read that exactly the way it's written because it I want you to be familiar with that because that's the way it's talked about over and over. However, what that actually means, it's not actually a problem. It's like saying, say I have a book here and I want to do a sample of this book. So I randomly choose the nth number as just a random number, or maybe I choose a 8. So I go to page 8 and take that page. Then I go to page 16, take that page. Go 8 more, and keep doing that, and that's how you would get a random selection. In the old days, we would literally take a phone book, and we would get every maybe 50th number, and that's how you would do a random sampling. So that's what every nth number means. A couple of other things. We're going to talk about different kinds of probability sampling. One is a stratified sample. So when samples are taken from subsamples to get representation. Now what that means is that you have subsamples, and so you'll sample from each of those. An example would be get a stratified, maybe a stratified age. So maybe you'll get a sample from college students, sample from middle-aged people, a sample from the elderly, and you'd have a stratified sample to make sure that all of those age groups are represented in your sample. So that's an example of a stratified sample used quite a bit. The next that we were going to look at is a cluster sample, taking samples from smaller groups for ease of use. Actually, this is used quite a bit, very practical. Maybe you want to find out how colleges are handling shelter in place. So maybe you take, or people are handling shelter in place. So actually you go to colleges, and you go to several colleges, and those are the groups that you select from to make it a little bit easier. Rather than getting a sample of the population, and a lot of those people won't be college students or the people you're looking for. So another example is zip codes. I actually used this in an experiment that I did. You take all the zip codes in the state, and I took 5 from each zip code in the state. It was Louisiana at the time. So I had a sample. They said, do you have a sample that represents the entire state? Well, yes, I do. And so that's really a random sample, a representative sample of a population of a state. Good way to do that. And zip codes are very different. There are some zip codes where people are not so wealthy, and some zip codes in Chicago where people are very wealthy, and some areas in every country that are like that. The last is snowball sampling. I've used this as well. The idea is that the original participants refer others whom are also questioned. I did this actually after Hurricane Katrina. So I talked to some people who had been affected by the hurricane, and I said, do you know any people who have been affected by the hurricane or displaced by the hurricane? They said yes. So they gave me the names of other people. Talked to them. I said, do you know other people who have been affected by the hurricane? And they said yes. So that's a snowball. It's not the best way to do it, but it's sometimes the only way to do it. So in that case, it's permissible to actually get a snowball sample. This is also called referrals because people are referring to other people. Okay, and we're going to be talking about a couple of other things with samples. We're going to stop right now with that.